So, greetings everyone. Now, today we are going to discuss more about graph data structures. And before we begin, we will begin with the short introduction of what data structures are for those who don't understand maybe data structures. And then, after some brief discussion, we are going to write some codes on how we represent graphs and the algorithms involved in maybe moving through graphs, through all the elements in the graph. Okay, now for all of you who know graph data structures, I know first of all you understand what a data structure is. And I like saying that data structures, these are ways of storing data so that we can easily manipulate it when we have it stored somewhere. Now, data structures are classified into two. We have linear data structures and then nonlinear data structures. And before we continue, I always love calling data structures bags. I mean, like sacks of maize, whereby these sacks we store elements in. Now, for linear data structures, elements are stored in a sequential manner. I mean, there is an order when it comes in retrieving or adding elements in linear data structures. I mean, for example, if we look at an array, elements are always arranged. I mean, from the first one to the last one. I mean, the first element to enter an array, we always index it at 0. And then the second element, we index it at 1. And so forth and so forth. Now, also, if we look at queues, we see that we have an order in which we insert or retrieve elements, or there is an order in which elements are arranged in that queue. We all know that in a queue, it's what do we use in a queue? Is it the leaf or the FIFO? No, we use a FIFO in a queue. Now, we know the first element is the one that will be retrieved first. And yeah, again, if we look at stacks, we can see we have that sequence, the LIFO, where the last in to be the first out. Then if we look at how data is stored in maps, we can see the key value thing and the keys are also arranged from the first to the last. Now, the second classification is the nonlinear data structures. Now, these bugs, the elements, they don't have an order in which they're arranged. The elements are just there. They're there. And since now elements are not arranged in any manner, these bugs always have levels. I mean, we have the top level or the root level, and then the other levels follow. Yeah, now back to graphs. So, okay, now what is a graph? We first know that a graph is an nonlinear data structure. Elements are not arranged in any order. Now, second of all, we know that a graph is just a group of nodes and edges. And nodes are denoted by circles, which might have data in them, and edges are just arrows or lines. Now, nodes, they are used to represent real life objects or the elements in that graph. Uh, Edges, on the other hand, they are used to show relationship between the nodes. I mean, we can say maybe when there is an arrow between two nodes, we can say that the first node and the other node, they have a relationship. In other term, there is also another term known as a neighbor. So a node that is connected to another node, it's referred to as the neighbor of that node. Yeah, now how can we use these graphs? I mean, how can elements that are not arranged in any order help us? I mean, since we know that nodes have relationships with other nodes, graphs can be used in prediction. I mean, let's take an example of an application whereby we have artists who just post their music on that social media platform. I mean, we can take the artists as nodes, and then since each artist posts something on the platform, we can look at the type of content that the artist posts, and then maybe we can look at another artist who posts similar content and then maybe tell them to do a collaboration or something. I mean, there's so many things that we can do with these nodes that have relationships. I mean, we know this example of cities. I mean, cities being treated as nodes and the roads connecting the cities being treated as edges. I mean, we can use also graphs maybe in calculating distances. I mean, maybe from one city to the other. We can use it also to calculate maybe the shortest route from one city to the other. I mean, you see how these graphs really can help the Uber platforms and the InDrive applications. I mean, look how the graphs can really help them. Yeah, we also know about Facebook. Facebook is also another good example of how graphs are used. I mean, you can see how the friend suggestion is done. I mean, if the users are treated as nodes, and then if one node is a friend of this node and maybe they share similar characteristics, then that friend is given to you as a suggestion. Maybe we can also use it to suggest food to certain groups of people. Maybe let's say you have an application that operates worldwide. I mean, if you see, if maybe the location indicates China, whereby now we're taking now countries as the nodes of our graph, and then maybe if the location indicates that we are in China, then maybe that node is supposed to be given certain food recommendations. I mean, that node is supposed to be given Chinese food only. I mean, there's so many things we can do with graph algorithms. And now, without wasting time, I know I've been talking too much, and maybe some of you want to dive into programming. Uh, we have also to discuss how we represent now the data in a graph. I mean, data is not arranged in any order. Now, how are we going to represent this data so that we can manipulate it? How are we going to group these cities together so that we can calculate the distances between one city and the other? Now, how there are two common ways of representing data in a graph. The first one is we use an adjacency matrix, and the second one is we use an adjacency list. And what is an adjacency matrix? Again, from mathematics, we've learned about matrices and stuff. So, what is a matrix?